Okay, hello and welcome to the SPE Industrial Partner Network and another SPE coffee break session. Nice to have you with us today. So my name is Ralf Schubert from the Marketing Working Group of the SPE Industrial Partner Network, and I will guide you through this next hour. Yes, with the update on semiconductors, we have an exciting topic today I'm looking forward to, and especially to our today's guest, Carla Linecar from EBV Elektronik, who I will introduce to you in a minute. Before we start, some quick information. Our webinar lasts about 45 minutes. If you want to ask questions, you can simply type it in the questions windows on the right side, and we will take up your questions after the webinar. And yes, as you know, the digital coffee break sessions are part of the ongoing SPE Pioneer Summit. On the platform of the summit, you will find the recording of the session afterwards, and not only this session, you can find all the previous sessions of the SPE Pioneer Summit there. For example, all keynote discussions and tech sessions from the huge Pioneer Summit kickoff in November is also available there. Yeah, and before we start, let's first hand over the word shortly to you. We thought it would be a good idea if we and you could get an impression of what the current barriers for a quick establishment of the IIoT are. And our plan is to have a quick poll together with you, and we will be able to see such results in a moment. So it would be great. So it would be great you would vote briefly. And here comes the poll. Please feel free to answer those questions. So question for today is, what do you see as the biggest current barriers to establish the IIoT? So there are 5 available answers. You can choose more than one if you want. The answers are missing devices, or missing standards, missing infrastructure, missing sensorics, or missing know-how. So we will give you a couple of seconds to vote before we share this result. I can see a lot of you already voting. This is fine. So the more of you vote, the better the result we get. Okay, see, some are still voting. Let's wait another moment. Okay, would say that's it. Many thanks. The poll is closed now. And here are the results. So yeah, so most of you, 72%, are saying it's the missing device. So that's a very clear point. Another very clear point is missing know-how. Yeah, on place number 3 is missing infrastructure, but also the others are even about 10%. And yes, I guess this brings us directly into the topic of today, and I'm happy to warmly welcome today's guest, Carla from EBV Elektronik. Hello, can you hear me?
Yes, I can hear you. Thank you for introduction.
Great. The result, missing know-how, missing devices, is this what you also see in your day-to-day talks, day-to-day chats?
Yes. I think especially in industrial, looking for industrial devices, for clear industrial focus devices, and also, let's say, it was not the highest percentage, but the standards. I think the IEEE organization are working on the extended reach inside the standards, and I think this is especially missing for industrial, and I will also talk about that in my speech. So let me try to share my screen. My screen. You see already my screen?
Yeah, we can already see your screen, I think. Yeah,
okay.
Now you're on PowerPoint.
Okay. Then I will switch off my camera, so to keep the bandwidth on the highest level as possible, that everybody can see that one. So I will make presenting mode. So, and
looks very good.
I'm ready, so hopefully you can see my screen. If something is missing or not happening, please give me a hint, because I have only a single screen, and I will not see the other things. And
looks totally fine.
Okay. Okay, perfectly. Okay, so then I will start. Okay, so so I'm working for EBV Elektronik, and at EBV Elektronik I'm responsible for the market segment industrial, and I will look more in the real industrial area, and I think this is also the focus of the Single Pair Ethernet industrial partner network. Yeah. So I prepared a short agenda. I will start with a short introduction to EBV Elektronik, and then I think I have an interesting page about the analysis of industrial use cases. And then I will came to present some parts from Broadcom, Microchip, NXP, and on Semiconductor. And also I will talk about existing evaluation demo boards, and also a media converter, which comes from the company Innovative, and this one is Broadcom based. I put that together with Broadcom here. And also I will talk about power over data line and the status I see so far. And in the last session before we came to Q&A, I will give you a short introduction to passive components which are needed in the application. And here our sister company Avnet Abacus has something to offer. So so with this, I will start with a short introduction to EBV Elektronik. So we are a specialized semiconductor distributor in EMEA. And we are belonging to Avnet Incorporated, and the Avnet, they have a speedboat model in EMEA with, on one hand, semiconductor distributors and also IP&E distributors and also embedded solution. Yeah. And so we are part, and we are the specialized one. We are founded already in 1969, so we are now 51, 52 years old. We see us specialized in deep technical support to you as a customer, and we see us as a full solution provider. So we can offer support to you beginning already with the idea, and here you can save a lot of money when you decide for the right part, for the right topology, and this can help you pretty well to make a really competitive product at the end. And for sure we will go through the complete design stage with you, and also helping you when it comes to production with sourcing, logistics, and all the other stuff around. So what does it mean, technical specialist, for us? So we are, and I mentioned that before, I'm belonging to a market segment. We have a segmentation. On one hand, we have market segments. They clarify the question what to use in an application, and then we have technology segments which can tell you the answer how to use a component and the solution. And I think this is the difference, that we get deeper into every stage of your design and help you on that. And we specialize also means we are not a broadband distributor having every semiconductor supplier in our line card. No, we have only 20 suppliers in a line card, but these suppliers are, let's say, out of our view, one of the major players in the industries, in the different industries, and also due to the reason that we are already a long time on the market. Inside these suppliers, we are in the network. In most of these suppliers, we are number one in the network. And this also helps, and we are deep in, and we know a lot, not only having a franchise and not knowing what they are doing and have no contact inside this supplier. And on top, we have an EBV chips program, and I never saw a distributor worldwide who has an EBV chip program. And that means a chip program means, in this case, we are able to define a new product, yeah, and it will be manufactured at one of our suppliers normally, and we offer that to and you will only get it from us, and it will be maybe not only hardware, could be also something in between hardware and software or something else. There are a lot of devices already in our EBV chips program, So we have a device which has a radio and wireless M-bus stack on board, especially for metering application. Or also we have a device which is called Heracles. It is an let's say an M2M communication module with integrated prepaid data package for 5 or 7 or 8 years or whatever. It is defining and it's working on 2G, 4G. It is LTE M based. So something which you can use directly and which helps you on that one. If you would like to know more on that, all this stuff, you can find a lot of information on ebv.com or even on our mother company, Avnet.com. So with this, I will go to, I think, a more interesting point for you to have an analysis in the industrial use cases. And we saw that with a poll that you are thinking that devices are missing. And if you look in case of industrial needs, yeah, you may be right, maybe not. But all the single pair Ethernet activities are driven more or less, and I will come on a later page on a little bit talk about the history, driven from the automotive. And in automotive, there are already millions of parts in cars on the road. And this automotive standard is already established. So the first thing starts, I think, in 2011, and the standard was ready in 2015. And with this famous 50 meters were defined, which you find in a data sheet. And my message here really is that in many cases, maybe even in most of the cases, you can use this automotive part. And even in the data sheet, it only says it reaches up to 50 meters. It doesn't says it stops after 50 meters. And also to keep in mind, in automotive, you really use an unshielded twisted pair cable. And the environment is really harsh with all the EMC around in the car and so on. And in industrial, we have more or less in most cases decided to use a shielded twisted pair cable. So I'm pretty sure that we reach much more distance than 50 meters with a lot of devices, and I will also later on show some products where we know already some datas. But when we look to industrial, in many cases 50 meters could be enough. So having a look to the automotive body shop segment in a factory, most of these segments are not bigger than 15 by 50 meters. So a 50 meter cable or 20 meter cable, which maybe even works, will fulfill the needs here. Or you have a serials machine, it's maybe in the range of 15 to 5 meters, so 50 meters will work. In a switching cabinet, they are mostly not bigger than 3 by 2 meters, so 50 meters will be more than enough. Most of the robotics applications, so they are small 5 by 1 or 5 by 2 or 5 by 3 meters, maybe 5 by 5 meters, but even here 50 meters is pretty enough. And especially in robotics, keep in mind that around the joint, the bending of the cable is one of the maintenance costs in robotics. So in many robotics applications, they change every 6 months the cabling. So if you can reduce the number of cables due to single pair Ethernet, it would be a big advantage. And I'm pretty sure that these cables are not longer than 50 meters. So you can use these automotive products for sure. But there are also industrial products there. So at the end, the message is, we believe that nearly 80% in industrial production machines or cells, the distance are not longer than 50 meters for the cabling. So you can use it. This is a message for that. So I mentioned this already. I would like to talk a little bit about the history of BroadR-Reach to single pair Ethernet. And when we look back, then we see that Broadcom was the inventor of BroadR-Reach for automotive Ethernet. And they start already in I don't know, 2000 something, but early before 2010, and they have had already first BroadR-Reach products, I think in 2008, 2009 timeframe. So, and then together with other automotive manufacturer and NXP, they formed an open de facto standard for in-vehicle Ethernet and founded an open alliance special interest group to drive the wide adoption of Ethernet in the automotive industry. That was beginning in 2011 for the open alliance. And the focus was really to licensing BroadR-Reach to other semiconductor suppliers to make 100 megabit Ethernet connectivity as a standard in the automotive network application. So this is really fulfilled, and now they're also talking about gigabit and higher speed rates, and even also smaller speed rates. So now what we see right now, we have two different organizations with two different, let's say, standards. So one is this BroadR-Reach standard for the open alliance, and the other one is the IEEE, the 802.3, with all the different under standards. And so the question here is, what is the difference between BroadR-Reach and the IEEE? And so there is a difference, but the main message here is really they work interoperable. So you can use a standard BroadR-Reach PHY from Automotive to communicate and be interoperable in the IEEE standard. But there are two small differences, and one is in the physical layer electrical test suite. Here in the 100 base T1 specification defines a test for the maximum transmit peak differential output. And this parameter isn't explicitly defined in the BroadR-Reach specification. So if you need that, then there could be, you have to do some tests and see if it works or not, whatever. And the second exception is that the 100 base T1 specification has some difference in the protocol timing to wake up commands to make those periods shorter. In many applications, so wake up, I don't know if you really need that in industrial at every time. In automotive, you need that to power down all areas, and this is something different. What we also see is that all new parts fulfill both standards in parallel. So only some older parts are not fulfilling both areas. So with that, I would start really to go on what is available on the market from different suppliers, and I will start with Broadcom. And what you see here is you see here two automotive Ethernet single pair Ethernet devices, or at least also families. The BCM 89811 is a 100 megabit device, and the BCM 8988X, it's a family with I think 4 or 5 devices at the end, and it is a 100 base and 1000 base device for PHYs. And also the interesting point is, and that is used later on in the demonstrator, it uses auto negation. All these devices are ICQ 100 qualified for sure, and the newer family also is able to do the timestamp for the IEEE 1588. So this is something what is needed for all the TSN and AVB stuff later on. So let's go next page. So this is this one. Just have to go to this one. Yeah, and this one is a BroadR-Reach PHY overview. Here the single port PHY, and this is an industrial product, BCM 54811. It offers all three speed grades. It offers auto negation, And the interesting point is, and I will switch on maybe my laser pointer, really is it supports extended cable reach application of 300 meters and 500 meters. So it depends, the end of the day of the cabling, even it supports in some areas for 10 megabit up to 1 kilometer. But then you will have a kind of a Cat5 cable or similar. If it is a twisted pair, unshielded, it will be in the range for 100 megabit in the range of 200 meters, and for the 10 bit for 500 meters. If you would like to have 1000 meter or maybe even a little bit more, you need then a shielded cable, something like a Cat5 cable. And on the other hand, we have the BCM5488X family. It's an octal port, 10 base, 100 base. And also here, if you have a shielded or unshielded cable, depends a little bit, you can reach extended distance up to 1000 meter. So Broadcom has some tests done, and they know a lot of that, but you don't find it yet in a data sheet, but hopefully soon. So having a look to switches from Broadcom, they have also switches, again starting with the automotive switches. Here we have the BCM895XX and the BCM8956X family. So one is again, the first one is again the 100 base T1 family. It also fulfills the EBV and the TSN protocols. Yeah, this is important for newer use today, and also the other family, it fulfills 100 and 1000 base. It also do auto negation and fulfills also the EVB and the TSN support. So okay, so then for sure Broadcom has BroadR-Reach switch products, the BCM 54500. It is for 100 base and 10 base. Yeah, it has up to 5 integrated PHYs, 4 dedicated for BroadR-Reach PHY, single pair internet interface, 1 dual mode BroadR-Reach and single pair, or 10 or 102 pair interface. It's a 7-port switch, and also it fulfills the IEEE 15888 peer-to-peer classification. So eval boards, especially for the BroadR-Reach PHY, for the BCM 59811, there is 11. There is an evaluation board, BCM 954811. It's available, and also there is a micro click board available from Microelectronica. You find that in the web shop from Microelectronica or at EBV, all these boards. So I mentioned that there is a media converter in place already. The company Innovative, they start with 100 megabit device. This is an automotive. They use automotive devices inside. Also, the design is an automotive design for up to 100 volt voltage classes, and they have a second one, which is an PHY, which can be switched between 100 base and 1000 base and can do auto negotiation. So this is available in their web shop. You can buy it already, and they are working on an industrial version, so they will use this gigabit solution and will make out of it an industrial solution with an instead of coupling capacitors, to have a coupling transformer inside to fulfill the needs of the IEC 61000. And they will integrate, instead of this connector, they will integrate the industrial connectors. I don't have a start of production now, but I believe this will come in the next couple of months, or at least next in the next quarter. And this media converter you can find already in a test installation in the smart factory in Ostwestfalen-Lippe. So maybe many of you know this area. The smart factory is located in Germany, in Lemgo. Here's a picture of the smart factory, and here's a picture of the installation. So this is an TSN, let's say, test installation to check the TSN functionality. So you can see here the installation, and make it a little bit bigger here. Again, you can see here the media converter, and before this Ethernet connector was connected here on this board, and then they bring in between these two media converters. So one is connected here, and then you have this twisted cable, this going down here, up here, and this is single pair Ethernet, and they really use a pretty simple cable to do some tests. So it's not a long distance, so you can also test it in longer distance then. And then the Ethernet cable is going in here, and it's working pretty well. And also what you can see here, you see here the LED is on, and that mentioned that this link is working on 100 megabit, and the auto navigation is working. So next supplier in our line card is Microchip. Microchip is well known and is a valued supplier in industrial and automotive markets. And they deliver first industrial automotive grade Ethernet devices to the market, and have a comprehensive Ethernet portfolio of PHYs, switches, bridges, controllers, and SoCs. And have a look a little bit deeper into that. They have a PHY, it's called LAN 8770. It's in full production since last summer. It's also an automotive based PHY. It's automotive qualified and all these things. The important things is really a low power operation, and also the power down in 50 microamps. So this is in the moment, I think, the lowest current consumption of PHYs which are on the market. And another point is really they are looking to extended cable reach. So what is working after, let's say, over 50 meters. And they said, okay, this is specified over a Cat5 cable. So you need then a shielded cable, could be even other cable which is not tested yet, and they reach out to 100 meter right now. This is something what they're testing. Microchip has also a switch family, which is called the LAN 937X family. You can see the different derivatives here. It offers up to 6 ports, and the PHYs are able to operate with 10 and 100 megabit, and also they do the auto navigation function there, and also you can see that here they have implemented the EBV and TSN functionality. Here an overview about the PHY and Switches evaluation platform. There are a lot of modular MCUs, daughter boards, and so on available. I think the interesting point will be the media converter they have. Here again, you see the connection for the single pair Ethernet, and here you have the standard Ethernet, and then you can test it in your installation you have today with standard Ethernet already. Also for the switch, they have a board available, and also the software is available, especially for the driver for that. It's also an important point, and we see that on this slide here. They have this MP Lab software switching tool, and in this tool are the software drivers are also integrated for Linux, for AUTOSAR, and for FreeRTOS. So NXP, what I mentioned before, NXP is also one of the, let's say, the first members of the Open Alliance group, and they have different PHYs and switches, and we see that here all on one page. So the TJ1100 was the beginning of the PHYs. So the second generation is the TJ1101/2, so single or dual PHY. And the difference between those two is that the new generation also offers the TC10. The TC10 is the wake up and sleep functionality, and I didn't mention that, but Microchip also has that implemented, and even in Broadcom devices, it depends on the device it is implemented. And maybe even I didn't mention that in Broadcom is in some devices already in the third, sometimes in the fourth or fifth generation. So here we see the second generation for the PHYs. The switches, so they have a 5 and a 10 port switch. So the 5 port switch is in fully production. Also fulfills the switch, the TSN functionality, the EVB functionality is also mentioned here. The SJA1110 is in sampling phase in the moment for selected customer in the moment. So it becomes to full production in the next couple of weeks, months. Also, there are tools available here again for the different PHYs, for the 1101, 1102. So for new designs, we would recommend they go for TJA 1101 or 2 for sure. And for that, I only put here the eval boards for these devices in. There are a lot of other tools available, especially for switches. I will not go deep into this. You see that it's named the SJ1105 in here, and some adapter boards and whatever. This is something about the Open Alliance TC10 Sleep and Wake Up development kit. So there is a lot available. You can find a lot on the webpage of NXP here. So coming to software from NXP, they have low-level driver available for the different devices that are mentioned here, Linux driver and AUTOSAR driver. Not all are free of charge, but the free software is provided without any warranty. So it is really for testing, and you have to verify it for yourself if you implement it. OnSemi, I add OnSemi. So the OnSemi parts are not on the market yet, but they are starting to develop in the 10 base T1S Ethernet, something industrial. These are purely industrial devices. And what you can see here with the NCN 26010, you have also an SPI interface, which is nice for industrial application. They use quite small packages, and in this device they have the PHY and the MAC integrated. I think that is a point, and remember that the T1S standard means in that case up to cable length of 25 meters in that case, and also these devices will fulfill the Open Alliance standard TC6, so for the SPI, and this is something what we can then see. We expected that they will also bring automotive parts of this family later on. To have the idea when they will be available, so it will take 1 year from now until we will see really start of production. So you can expect them in Q2 2022. So this was the overview of PHYs and switches, and now I would like to go to the power over data line. And I think here the situation is a little bit more tricky in the moment than with PHYs and switches. But I will repeat one slide you have shown when you have seen the coffee break session from Matthias Fritsche last time. He was also talking about the standards and about the power classes, and I took this slide again. And for industrial, so we are looking normally in the range of 24 volt, and we have two different standards, the BU and the CG standard. For industrial, maybe especially when we look to 10 base systems, this is a CG standard for 10 base. That will be this area which we are looking to. So so we have to do some devices here. In other applications, you will use different voltages. So like 48 volt would be interesting for automotive, but also 24 volt. So depending on cars, it will be more 48 volt for the future. If you look to trucks and all this kind of vehicles, it will be more the 24 volt. Maybe it will change, nobody knows yet. And there are also other applications where it could fit. But I think our target will be 24 volt. Here again, the power over data line function out of the presentation from last time, and you have two ways. So if you don't know what your device needs of power classes, so what we saw before, and you don't know then the voltage and all the other stuff, then you need a serial communication classification protocol. And that really means you need something to provide where a microcontroller is in, whatever. And what we don't have right now are parts for that ready. So you have to do this by your own, and you have to do your own software and so on. And I think this will also take a time until we will have parts for that. But if you do a so-called engineered power system, so engineered means you know what the PD needs for power, yeah, then you can set up the power accordingly. Then you can follow up the standard scenario, only do a test link check, test 10 milliamp if the device is there. If you see the 4 volt here, then you switch your power on, and because you know what voltage and current the PD is needed. And that brings me then to the next slide, talking a little bit about that. So what I mentioned before, so engineered power system means knowing the PD, knowing the power requirements of the PD. So PD means power device. Sorry, I didn't mention that before. You know the cable length, the type, and the position, whatever. Maybe you don't need that really, but at least the cable length could be an interesting point, depending on if it's high power or something like that. Then you will power up directly. You will do no power detection. You don't have to do a power classification. You have done that before. At the end of the day, the only thing what is needed is the power source equipment. It has to endure the inrush current during power up, and the PD should limit the inrush current during power up. So yeah, to keep that in mind. And for power failure, so the PSE needs an overload protection, and the PD has to have a low voltage monitoring. So what does it mean in kind of devices? So you can use everything for a PSE. You can use a standard AC/DC. Maybe you need an eFuse and some other components around, and can build up your PSE by yourself. And also for the PD, you use a power sequencer to detect if there is power on the line. Then you power up your DC/DC, and again you have an eFuse and some other parts around, and you have your PD in place. So the situation in the moment is that there are not complete components available on the market, which you can use directly like you see by Power over Ethernet. So I know that some of our suppliers are working on that, and they will come, but this will take a little bit time again. So, but nevertheless, you can start right now, and also some of our suppliers, they have already some demonstration boards in place. So let us know what is your need, and then we will check what we have and what we can do together and where we can help you. So with this, I'm coming to the last part of my presentation. Would like shortly introduce our sister company Avnet Abacus, and then came over to give you some hints on transformers in the end. So Avnet Abacus is also part of Avnet, like we as EBV. They are focusing on IP&E, so key technologies are interconnect, passive, electromechanic, batteries, power conversion, sensors, RF, and wireless. They have also brought Linecar. They have a sales territory, also EMEA. They have similar location than we, and you can get in touch with them. We are Avnet abacus.com. So having a look what they can offer for single pair Ethernet. I think the interesting point here is that they have for the coupling, the LAN transformers, the chip side common mode chokes, the line side common mode choke, and the dual different mode chokes in place. Also, they have TVS diode area over voltage protection in place, and you see here the block diagram. So for everything they have the inductors, and one of their main suppliers here is the company Burns, which supports you. And here you see again the email or the web page, and the email, the web page address, the avnet/abacus.eu, where you can find much more deeper details or get directly in touch with them. So with this, I'm coming to the end of my presentation, and would like to say thank you, and hopefully we will have some questions. So I would like to, Ralf Schobert, do we have some questions? Should I give you back the presentation mode? I can't hear you. My screen. Stop sharing. I think you are muted. You are muted. So I can't hear you. I think you are muted.
Can you hear me now, Karl?
Yeah, now you're here. Okay, perfect, Ralf.
Okay, sorry, I don't know, technical issue. Can you still hear me?
Yes, I can hear you. Perfect.
Okay, great. Yeah, many thanks, first of all, for this great update and insight. And yeah, as you mentioned, first question already came in, and we can right start. So also an invite to all our attendees. So if you have any questions, you can still ask them, and they will be answered here. So first question was very early. I just read it. Is this auto-negotiation part of a standard, or only usable between the BCM 8988X? Is it understandable?
Yes, if I understood that question, I'm not sure. I'm not deep in the standard, so I never read the standard itself. I know that it comes more and more. What I understood so far is that everybody who's using standard Ethernet knows by himself. He puts in the RJ45 jacket somewhere, and nobody takes care. And then normally there is an auto negotiation standard in place between different speed grades: 10 megabit, 100 megabit, 1 gigabit. As I understand so far, this is not in the standards of the single pair Ethernet in the moment. And I think this is a little bit the difference. And also we have to keep in mind that the 10 base T1 standard is the T1S for short range. This one is a half duplex standard, and the T1L is a full duplex standard. So this will not work in the moment. So you have to decide you in the moment for that. The device itself, they implemented that already, because suppliers like Broadcom, they have, on even Microchip and NXP, they have experience about standard Ethernet and know that very well and implemented that. So it is working. But I think it's not really part of the standard. But I'm not sure on that topic really, because I never read the standard at all. So this is only my information I have. So you have to check it again by your own. But I think especially with the 10 base T1, it is pretty clear.
Okay, many thanks, Alex. The next one is, it's a very short one, but I guess you will understand it. How about a mixed vendor application? We say, what about that?
It's a good question. This will work. I'm pretty believe on that, because if everybody is compatible to and interoperable to the standard, it has to work. Otherwise, it will not fly. So the situation what I see today is that a customer only decided for one vendor, and then he will be only able to test it against himself, and there are not so many things on the market in the moment. Yeah. So what you can do is, if you would like to test that, you can use maybe the media converter from Microchip, and buy a media converter from Innovative, and then you have 1.5 from Microchip and 1.5 from Broadcom, and you can check already if it's working or not. And I think this is something what will came later with the alliance, maybe, and we have that had in the past, even in other technologies, that in the beginning we need some kind of, I call it a plug fest, yeah, where customers can come with their ready designed devices to check against each other if it's working. Yeah? So if you mean it in between your device itself, it should work. Why not? I believe it will work, but I don't have experience for that, and even I didn't saw that customer has done that yet.
Okay, also the answer, I think. So the next one is a longer one then. So in the 10 megabits per second 1 kilometer case, the local earth potential rise difference between the PSE and PD during a lightning stroke can reach 10 QA. What protective measures should be adopted to prevent equipment failure?
Good question. Pretty good question. I'm not so familiar anymore with the standardization like the IEC 61,000. So I'm more than 20 years right now in sales. But before I was a development engineer, and I was looking in things like that. But if that is in there, what I don't know yet, then it will be tested, whatever. We have to see. I don't know yet. Even I think the application which needs really 1,000 meters, there are not so many at the end of the day. I think there is a lot in between, let's say 100 meter and something, whatever, depending on the industry and where it is. But yeah, it's an interesting question. So I think the end of the day, in the moment the situation is you have to test it by your own in the beginning. Yeah, hopefully we find somebody, maybe from a university or Fraunhofer or some other institute, or even the mentioned smart factory guys, that they will start to test something like that. And this could be even something what you, if I don't know if you do that as a customer, but you can do that easily. You can make a bachelor or master thesis out of that and bring that to any university somewhere. This could be an interesting point to really the influence on that and to a study on that. And this is, out of my view, that is kind of a cheap way to find such things out.
Yeah, indeed, I think it's very good suggestion. Okay, the next question then is on PoDL. So the question is, when do you expect PoDL to be integrated into SPE chips?
So I would say it starts right now. And when I look to our franchises we have so far, I expected latest integrated devices in 2023-24, something like that. So 2 to 3 years from now, I believe. I see there are activities, yeah. So what we are trying to do is in the first step to really have some demonstrators for it and reference designs for it, to help you to make your design easy with existing parts to start today. And the next step then will be integration.
Great, many thanks. So if you like all our attendees to ask more questions, you are welcome to do. We have 3 more so far. So the next one then is, you mentioned that the 100 megabit PHY from Microchips offers extended reach to 100 meter. Also Broadcom PHYs offer longer reach. Is this already documented in the data sheet?
It's not documented in the data sheet right now. There is only the 50 meters mentioned. They are in an early phase. They test it, and hopefully they will implement that to the existing devices in the data sheet, or at least that they will put it in application notes that you can use it and that you have a reference. How they have tested, which cable they have used, what was in environment, whatever. I know in the past with the first BroadR-Reach parts from Broadcom, there was some longer distance mentioned in between, but they removed that. I think that was the result out of the standardization for the Open Alliance group.
Okay, great, many thanks. So next one then is one of our attendees mentioned I missed roadmap information. So could you tell us more here?
Okay, roadmap. We have some roadmaps in. So I think a good roadmap information was on Semi. Yeah, they give you an advanced preview for 1 year. I think this is pretty nice, and there will come more for sure. Besides this device, all our suppliers have roadmaps in place. Yeah. And for sure they have roadmaps for automotive, but also for industrial parts. In the moment, and this is the background a little bit, you will not find any data sheet without NDA in the internet at all. And maybe you find a flyer or some pre-information, but not a full data sheet. And you will also only get data sheets via NDA, and also the roadmap information only against NDA. And that means if you're interested on that, get in touch with us. We will set up a meeting with the supplier, and then we can do case by case. So we even are not allowed to do a complete NDA with you and then provide all information of all suppliers. So we have to do this with every single supplier. We have to do that. It's a little bit, let's say, more complicated in the moment, but this is the situation right now.
Okay, many thanks. And then one final question for today's session. You gave us an overview of a Broadcom, Microchip, NXP, and on Semiconductor. Are this all the vendors, or are there other suppliers with PHYs, switched or PoDL devices?
Yeah, so there are others. So I mentioned that one which are in our line card. But there are, as I'm aware of, maybe there are some more. There's Analog Devices also in the game, who is doing devices for industrial, also for TEM-based T1L, something like that. In the automotive area, it's Marvell and Realtek, which has PHYs and switches. And for PoDL, it is still the situation. I don't know any supplier in the moment. Maybe I missed that one who has a ready device. So I don't think there's any PoDL integrated device on the market yet. Not for PSE, not for PD. Okay.
Okay, many thanks. No more questions then for today. Kalinov, many thanks. I think that was a great update. Many thanks for that.
Okay, thank you very much and have a nice day.
Many thanks, yes. And before we close, just some notes about the upcoming sessions. As you might know, the SPE Pioneer Summit is an ongoing session, and we will present this kind of session every 4 to 5 weeks with a new topic. So the next one is in early June. Not to mention too much, but expect the next invitation very soon. And also, if you also have a topic for this kind of session, you could always ask us and contact us and get in touch with us. So, for example, prototypes would of course be a very great topic, and we heard here and there. So some prototypes might be there already. So if you want to introduce prototypes also here or any other topic, you're welcome to get in touch with us. And yeah, with it, I would like to say thank you for joining us today. See you next time then. And very important in these times, stay healthy and have a nice rest of the week. Many thanks and bye-bye.